So these things tomorrow I will try to make slide for stereochemistry of allenes and related compounds, how to determine RS configuration in those compounds. It is very difficult to discuss those that one through this method, but I will try. Regarding that, regular class mode is better to explain RS configuration of those kind of systems. But we will try to finish here. There is no choice, so we will do it here. So today we will discuss stereochemistry of fused, breezed, and caged ring system. Here, caged ring system is also called. Two types are there. So caged and adamant are very much close words, and fused term is also there in your syllabus. So we will start here. So by the name, we can say that breezed. Overall, this is cyclic system, ring system, stereochemistry of ring systems. So first we will see what is breezed bicyclic rings. Mainly three kinds of breezed bicyclic compounds are there: breezed, fused, and spiro. Breeze means simple bicyclic systems. A breeze of atom is thrown across from one side of the ring to the other side. Okay, and fused system is bicyclic compounds, one bond common to both ring. Okay, and spiro compound, one atom common in both. Here, this is the example of breezed by a breeze of atom. This is a breeze kind of atom. This one. So this is breezed system. This is fused system. One bond is common. Spiro, one atom is common. So these are three systems, three examples. Now, how to do naming of this kind of system? One example we have taken, this is Narborane system. The total number of carbon is here 7 carbons. 2, 3, 4, 5, 6 carbon. This one is here. Total 7 carbon system. So parental name will be heptane. Okay? Methane, ethane, propane, butane, pentane, hexane, and heptane. So heptane is the parental name. The total number of carbon between the bridgeheads are bridgehead carbon are which two are bridgehead? This carbon and this carbon. So either this will be first or this will be first. We can start from anywhere. Okay. So these two are bridgehead carbon. So total two. If you will from go one bridgehead carbon to other bridgehead carbon, then by this pathway 2 carbon, this pathway 2 carbon, this pathway 1 carbon. Total 3 pathways are there. Okay. So total number of carbon atoms between bridgeheads are 2, 2, and 1, and they will be placed in a descending order between brackets separately by tools when we are going for nomenclature. This example you can see here, Narborane bicyclic system. So first we will start bicyclo. This is bicyclic system. In bracket we will write decreasing order of number of carbon atoms in different pathway. So 2, 2 both are same. So we can write any two first. So 2, 2, and this pathway 1. So in bracket 2, 2, 1, and parental name is heptane. Okay, just like in our name, title is there, that is parental name actually. So here parental is heptane. Now this bicyclo system we can see how many pathway are there to reach from one bridgehead to other bridgehead. 3, 0, 3. We have to write in decreasing order. Bicyclic system, so bicyclo 3, 3, 0. And how many carbons are there? 8. So heptane, after that octane. So family name is parental is octane. And this is spiro system. So we will write spiro here. Okay. 4, 4. 4 this side, 4 this side. So 4, 4, nonane. Spiro is there, that will give indication that one carbon is common. Total how many carbons? 9. 4 are breathing carbons. It means one is common. So 8 is here, one is common. Okay. Now conformation. Compounds with two or more ring fused together, just like spiro, then that is spiro. And bicyclics means two rings that share two or more common atoms. Okay. So this is the difference here. You should know. Now reaction. Breezed structure are generally very rigid, generally adopt a single conformation. Attack on unsubstituted breezed ketone occurs predominantly from the side of the one atom breeze rather than the two atom breeze. Why? You can see here. This is the Narbonne. Attack may be from this side, maybe from this side. Which will be preferred? Two options are there. Lithium aluminum hydride is used for reduction. So there is formation of two products. In one product, hydrogen is attacking coming from this side. In other product, hydrogen is coming from this side. Okay. So you saw here the unsaturated bridge ketone occurs predominantly from the side of the one atom bridge rather than the two atom bridge. Okay, it means attack should be from this side, not from this side. Okay, so here which product should be dominating? This is the dominating major product. Okay, in this case you can see camphor. Again there is reduction. Okay, so again hydrogen is coming from hydrogen. If this group is not there, okay, if this group is not there, these are not there, then attack will be preferred from this side. But in this case, this is reverse. A complete reversal of selectivity is seen in camphor due to steric hindrance on the side of one atom. This side is sterically hindered, that's why this will be preferred. Otherwise, it should be preferred from this side. But sometimes exceptions are always there. And a bicyclic system can be further fused and breached. So these are some other examples. Now, so in this case, two faces of ketonic groups are there. What is the name of these two faces? For example, if double bond is here, so this is indo, okay? Exo. Here in this case, Narbonane, which is exo and indo. This is endophase and this is exophase. Okay, endophase, exophase. So steric hindrance in the bridge cyclic compounds govern the selectivity of the products by directing the attack from exo or endo side. Okay. How exo and endo? If there is any confusion, actually you can see this stereochemistry of this bond is this is just like book, and direction of this is towards below, direction is below. So this is coming in inside this book and this is coming outside the book. This is also inside book, outside book. Okay, that's why this is exo, this is into. Okay, This effect can be seen in Grignard reaction also. For example, this here you can see here, this is the Narbonne name. Now, two options are there, exo or indo. But as I told you, if there is no steric hindrance, this will be preferred from this bond site. So exo will be preferred. Product is this one. This is another reactant where some steric hindrance is there. That's why indo will be preferred. And this narbonin exo attack will be preferred. No steric hindrance is there. In this one, steric hindrance is there. So indo will be preferred. Now you can see another reaction going to react. We are just treating with strong acid. Strong acid and HNO3, that is a good oxidizing agent. So if you will oxidize this with HNO3, then it will convert into OH and double bond will be there. So how it is possible? You can write a mechanism also. Means this bond will move here and this bond can move here, and there will here double bond is also generating. So how it is possible? So it means one hydrogen from here will be released. Okay, so how this will be released? And that hydrogen should come here. So what is possibility? If this bond will come here, this keto bond, double bond will move towards oxygen. Negative charge will be developed here. That will take proton from a strong acid. Okay. Now here plus charge will be developed at this carbon. So this here two hydrogens are there. Now this conjugate base of this acid will take this proton, and this C carbon hydrogen bond will make a double bond here. Okay, in all field form. Now oxidative cleavage next step. This bond will cleave and it will form COOH. And if you will treat with acetic anhydride, then this will convert into anhydride. Okay. Now conformation of decalene we can see fused bicyclic system. What is the name here? Bicyclosystem this is. So how many bridged carbons are there? In three. This is bridgehead carbon. This is bridgehead carbon. How many roots are there? This is one root. This is another root. This is third root. So in bracket we will write the number of carbon atom in each root. So in this root 4, in this root 4, in this root 0. So 440. Parental name decane. Okay. How it can be prepared? Saturated analog of naphthalene can be prepared from it by hydrogenation. Means if you will do hydrogenation of naphthalene, you will get tetraline, and you will further go for hydrogenation, you will get trans and cis, two types of decoline. Now we can see here. So two decaline systems are here, cis decaline and trans decaline. Cyclohexane, we are knowing that cis and trans, in that one it are both, they are interconvertible. In this case they are interconvertible or not? So Sake Mohar proposed that this is not possible. We are going to break the bond. Without breaking and making the bond, this conversion is not possible. Now you can see the cis decaline is like this. And transdecaline, this is chair form. One chair form of one ring, other chair form of other ring, one chair of this ring, this chair form of this ring. So this is cisdecaline, transdecaline. Okay. So these are the bridgehead carbons. Okay. This and this. Here, this and this. So if you want to convert, this part is common here. Now, if you want to rotate, you want to bring this hydrogen here, this bond here, how it is possible without breaking? And you want to fix this one. This carbon is okay. Only you want to change this one. So it is not possible. If you will do this way, this bond will break immediately because this will be affected. So this is not possible without breaking the bond. Now you can see here properly also. Cis decalin is existing. Cis, both hydrogens are cis with respect to each other. Both hydrogens are trans with respect to each other. Now you can see here, each chair is fused to the other by equatorial bond. Okay, this chair and this chair, they are fused by their equatorial bond. This is equatorial bond. Okay, so leaving the angular hydrogens axial to both rings, the hydrogen on the ring junction carbon trans in this diastereoisomer. Whereas chair conformation of the ring fused by one axial and one equatorial. So this carbon bond is axial, this carbon bond is equatorial. In this case, both are equatorial. So here this connection is different. So this structure is bent at the ring fusion, C1 axial and C6 equatorial. So the hydrogen and the ring, these two are cis with respect to same side each other. Now transdecaling, you can see conformally this is logged frame system. Logged means it is difficult to rotate. So it will not undergo inversion reaction. Inversion. And this is a chiral system. Center of symmetry, midpoint of the 9-10 bond. Okay. C2 axis passing through C2 and C3, C9 and C10, C6 and C1, C7. Now cis decaling. You can see this is a proper structure. Cis isomer is chiral without chiral center. Two-fold rotational symmetry along going through the center of 1,6 bond, but no reflective symmetry. However, the chirality is cancelled through a rapid chair flipping process that turns the molecule into its mirror image. Hence, that compound is not resolvable. Has a folded structure with convex and a concave side, so that the steric interaction are uniquely distributed on the two sides. Now ring flipping and ring inversion, we will see here how it is possible. Each ring in cis decaline can undergo ring flip forming two different chair conformation of equal energy. Now we can see here, this is chair form, this is chair form. And one is they are, this is cis decaline. Okay, means at connected, this is the bridgehead carbon. So one is axial this side, and this is equatorial this side. Okay, both are same side. So this will be cis molecule, and this can this can interconvert into this form. Okay, means what will happen here? This is the sixth carbon. Okay, this is first carbon. Earlier this position was here. Now in this one it is here. When this will rotate and convert into another one, this will come here. And these two bond will also move with that one. So it will convert into this form. You can see this structure also. This interconversion is possible. Each of the angular hydrogen is oriented axial to one of the ring and equatorial to the other. So this relationship reverse when double ring flipping converts one cis conformation into the other. You can see this is the structure of this one, cis with respect to each other. transdecalin capable of ring flipping because a ring flip one ring would cause its two alkyl substances to be apart to accumulate the second ring. And CH2 group is insufficiently long to breach them. Transdecalin is said to be conformistly locked because it cannot undergo ring flip. Means you can see here if you want to flip it, okay, this example. So how it will possible? These are the two carbons. These are those two carbons. So how it can be flipped? This will go up, okay, and this will go down. Only two options are there. This is equatorial. This is equatorial. Both of them can convert into axial. So this will go up. This will go also down. So overall, this is highly strained molecule. So that is not possible. You can see this is how we have discussed in previous example. Means these two are same direction, cis, cis. So this can convert into this and this can convert into this. But in this case, they both are opposite with respect to each other. So if we will convert, then this will form. That is not very stable. That is not very good. That's why this flipping is not possible. Cis versus transdecalin. Now, trans isomer is about 2.7 kilocalorie per mole more stable than the cis isomer, largely because of relatively unfavorable non-bonded interaction within the system. The small difference in the entropies of the cis and trans isomer also suggests the more stability of transdecalin. Now we can see this molecule. Gaussian unit exists in transdecalin as the two rings are joined together through E bonds. So equatorial bonds are bonding. So transdecalin as the two rings joined together. So Gaussian unit is not existing in this. And in cisdecalin, three Gaussian interaction exists as the two rings are joined together through E bonds. The difference in enthalpies is therefore equal to the 3 Gaussian interaction, means 10.05 kJ per mole. Experimental value is this one. 0.2. Breezed ring compounds. What is breezed ring? Again, we will see just like previous one. In a breezed cyclic system, two rings share two carbon atoms. And these carbon atoms are not adjacent. So, bicyclic system, first one there is three pathway to reach bridgehead to bridgehead. So 3, 2, and 1. So in bracket 3, 2, 1. Bicyclic system, bicyclo 3, 2, 1. 15. Total number of carbon is 7. The same way this one also. Now you can see here bridgehead, 1 carbon bridge, 2 carbon bridge, 2 carbon bridge. Okay? Bicyclo 111 pentane, smallest ring system. This is the smallest ring system. Oh my. So bridged head carbon are very close due to the small endocyclic valency angle. These two are bridge head carbons. These three bridge heads are there. So they are very close due to bond angle. Unstable and converts to 14 pentadiene on heating. This will convert into this. Now bicyclic heptane system, Narborane, we can see different examples here, how they can convert. This is, this will convert into this. Now this is like this. Now we can see how uh, Newman projection can be used to show the bond. This is another molecule. This is after reduction converted OH and like that. Yeah. So these are different Narborane system, bicyclic system. This is having ketone group. So how reduction takes place? What are the conformation that exists like this? You can see here. Bicyclic 2 to 2 octane system. C1 and C4 are joined by ethylene bridge. So all are similar. So what will be the name here? Bicyclo bracket 222 and total parental name is octane. Other bridge tolerating system you can see here in this. This is bicycle. This is monocyclic system. These two are. This is the bridge carbon. So how? What is the name here? Bicyclo. How many? These two are bridge carbons. So how many pathway? One is this one. One, two, three carbons. So three. This way one, this way also one. So three, one, one. How many carbons total? Seven, six this, one this. So heptane. In this one, three methyl bicyclo. So first, what are the groups we have to see? So oh, these two are here and one is here. So first we should give numbering. We can give numbering here. So one will be here. One, two, three, four, five. Six. So how many here? So if these two are hydrogen, then this name is correct. Otherwise, this name is not correct. Only if this is correct if these two are hydrogen. So in that case, you will give numbering. Then one, two, no, one carbon. First carbon is this. One, two, three. One, two. This name is not correct. Here should be 1, 2. So 2 methyl, bicyclo, 3 carbon this side, 1, 1. Bicyclo, 3, 1, 1, and total carbon will be 6 and 7 and 8. So the total carbon will be no, so this methyl is written here, so that will be 7. So heptane. And this bicyclic system, these two are bridgehead carbons. This is one pathway, this is another pathway, this is one pathway. So this pathway 3 carbons. So first we will write 3. This pathway 2, 2. This pathway 1. So bicyclo 3, 2, 1. And how many carbons total? 8. So octane will be the parental name. Okay. Now another system we can see here. Bicyclo system, little bit bigger. Both are in chair conformation. So how we will give name here? Bicyclo system, and you can do by yourself also, and you can check it is possible or not. So you can see here 3 carbon this side 3 carbon, so 3, 3, and this side 1 carbon, 1. Total number of carbon 9, so no name. Bicyclo 331, no name. And this one also you can see these two will be bridgehead carbon. So this side 3, this side 3 carbon, and this side 1 carbon, 3, 3, 1. molecule also. Now adamantane, this is an propellant. When the two breeze head atoms are joined by a single bond, a tricyclic system is formed where the rings share two bridgehead atoms. These are called propellants. A tricyclic compound may be formed by four bridgehead carbon atom, as in the case of adamantane. Okay, propellants having three bridgehead, adamantane having four bridgehead carbons. These are some examples. Tricyclo 110 pentane. So total four routes are there from reaching one bridgehead to other bridgehead. In all direction, one carbon, one carbon, one carbon. In these three pathway, one carbon, and this one pathway having zero carbon. So tricyclo 1110 pentane. In the same way, we can give nomenclature of this system also. This system also. If any confusion, you can ask me in next class. This is also called another way it can be defined that a maintained molecule consists of three connected cyclohexane rings arranged in the armchair configuration. So if both ring rigid and strain free, how it can be synthesized at a maintained hydrogenation of dicyclopentanone in the presence of platinum oxide as a catalyst, followed by its transformation into adamantane using aluminum chloride, a Lewis base. What is the role of Lewis acid? What is the role of Lewis acid here? So that will promote the reaction, that will give pathway to start the reaction. Okay. First, it will convert it into saturated one. Then AlCl3 is used. AlCl3, you should remember, it is many places it is used to convert into another isomeric structure. So here also this is used for that purpose. So two six-ring system and one three six system are here. So you can see three six two four two six 1 2 3 4 6. Now there is Brett's rule. You should remember this. In many exams, there are some examples that which one of the following is not correct. You should know where double bond will exist, where it cannot be exist. So the double bond cannot be placed at the bridgehead carbon of a bridgehead ring system unless the rings are large enough. Therefore, the two isomer of norbornane violate Brett's rule, which makes them too unstable to prepare. Okay. Now, how this reaction takes place through with this adamantane? You can see here how it is reactive. It will react with bromine in presence of iron. It will react with bromine in presence of aluminum chloride Lewis acid. It will be done bromination in presence of iron. And another one is done bromination at high temperature only. Now carboxylation of adamantane, how this reaction takes place. This formic acid enters butanol and H2SO4 and CCl4 is solvent. So this will be used as a salt of acid. Then if this acid will react with adamantane, all acids are oxidizing agent, but this is per acid. Per acid is a very good oxidizing agent. So this will first step is in this case CCl4 will take part in reaction, just like cell Riemann-Tiemann reaction. Formulation reaction is there. Formulation reaction is done in that case So CHCl3 can attack on the ortho of the phenol OH. Then that can attack in in that place and convert into the COH. Means CHO can be converted into COOH. First CCl4 will take part in reaction, then it COOH. Some other reactions you can see here. This is a maintained and reaction is very much similar. Okay. Now rearrangement involving the substituent and maintain undergo acid catalyze peripheral shifts easily. How this is possible? Means this halide will really undergo this halide will readily it can undergo at bridgehead carbon. Means this will move from here to this bridgehead carbon. This is not bridgehead. Bridgehead carbon is this and this. This can simply other point means more than one substitution is there. So how it is possible? We are going to expose this molecule with 96% H2SO4 at 70 degrees centigrade, then it will give good yield. And it in this experiment, we also found that 96% of H2SO4, one elemental exists at equilibrium with two elemental of the mixture of at 2 degrees centigrade. So here experimental revealed that 96% of H2SO4 exist in equilibrium with 2% of the mixture at 25 degrees centigrade. Thus, it was suggested that ketone is formed by disproportionation and a direct oxidation of the secondary alcohol. That's why that reaction will take place in that pathway. Means, and you all of you are knowing how H2SO4 can react with anyone. H2SO4 always gives reversible reaction in many cases. So at any place, if we want to react and we want to remove, then H2SO4 is the best option for that case. So here also that is taking part in reaction, and we will get the isomeric product. Okay. So is there and cis and we should also know about cis and trans little bit. I am going to discuss here. For example, this is the molecule here, and two bridging groups are two groups are attached here and here. For example, in this case also, one group is here, one group is here. If both are in same direction, then they will be cis. If they are in opposite direction, then they will be trans. That is, this is a geometrical isomerism of cyclic system. So this way we can decide that which is cis and or trans. Okay, in any molecule. This is the method to know the compound is cis or trans, same with the stereochemistry of the compound. For example, here in this example, we cannot say these for these two. We can say only about these and these and these. If these two are in same direction, uh, then it will be cis with respect to each other. If you are both are not in the same direction, then this will be trans with respect to each other. Okay, I think time is up now, so we are going to stop here. Again tomorrow we will start. Okay, so Now we are going to stop here. Okay, from tomorrow I will try to activate pointer. Today I missed your message in chat box. I will try to activate pointer. Okay. Thank you for this reminding for this. So tomorrow again, same time we will meet.